Introduction. This section has requirements to ensure that products are controlled properly. They are achieved through all phases of handling, storage, packaging, preservation and delivery. These measures will ensure that damage or deterioration of the product is prevented. Documented procedures ensure that the product remains undamaged. They will not suffer deterioration. Raw materials must be secured and segregated in storage from finished materials. There needs to be documented procedures for transfer of materials. Formal and documented packaging procedures, marking requirements, and instructions must be under controlled systems. And of course, personnel must be trained. The delivery of the product must be in accordance with the contract. The supplier is responsible for getting the electronic product to the consumer. It may be commercial or defense in the condition. It will work to specify requirements. Again, these are documented, auditable, and established processes with specification and standards. It applies to all processes: business, support, and product hardware, software, and services. Internal procedures, including flowcharts, should be generated for this area. Each company should have standard practices that all employees use. Consumer products are a good example. Items like a television or home appliances have lots of packaging and plastic cover areas. Electronic equipments. Let us see how to handle the following electronic equipments: laptop, multimeter, oscilloscope, fingerprint reader, industrial motor drive, quadcopter. Laptop. A laptop can effectively be turned into a desktop computer, a hardware frame that supplies connections for peripheral input or output devices such as a printer or a larger monitor. Laptops usually come with displays that use thin screen technology. The thin film transistor or active matrix screen is brighter and views better at different angles. Safety measures. Ideally, keep the computer in a clean and dust-free room. Keep food away from your laptop. Be sure to plug accessory devices into their proper slots. Handle any removable drives with care. Insert drives into their slots carefully and at the correct angle. Try to keep the laptop on a flat, clean surface. Don't use your laptop on the bed. Use an old toothbrush to clean the area around the exhaust fan screen. Avoid placing heavy materials such as books on top of your laptop. Multimeter. A multimeter or a multitester is an electronic measuring instrument that combines several measurement functions in one unit. A typical multimeter would include basic features such as the ability to measure voltage, current, and resistance. Analog multimeters use a microammeter whose pointer moves over a scale calibrated for all the different measurements that can be made. Digital multimeters display the measured value in numerals and may also display a bar of a length proportional to the quantity being measured. Measuring voltage. To start, let's measure voltage on a AA battery. Plug the black probe into COM and the red probe into MAV ohm. Set the multimeter to 2V in the DC, direct current range. Almost all portable electronics use direct current, not alternating current. Connect the black probe to the battery's ground and the red probe to power or positive. Squeeze the probes with a little pressure against the positive and negative terminals of the AA battery. If you got a fresh battery, you should see around 1.5 V on the display. Measuring resistance. Normal resistors have color codes on them. Pick out a random resistor. Then hold the probes against the resistor legs with the same amount of pressure. The meter will read one of three things: 0.001 or the actual resistor value. In this case, the meter reads 0.97, meaning this resistor has a value of 0.97 k ohm or about 1 k ohm or 1000 ohm. If the multimeter reads 1 or displays OL, it's overloaded. You will need to try a higher mode such as 200 k ohm mode or 2 mega ohm mode. If the multimeter reads 0.00 or nearly 0, then you need to lower the mode to 2 k ohm or 200 ohm. Measuring current. Insert the probes into the correct connections. This is required because there may be a number of different connections that can be used. Be sure to get the right connections, as there may be separate connections for very low or very high current ranges. Set switch to the correct measurement type, that is, to measure current, and range for the measurement to be made. The range on the multimeter can be reduced later if necessary. However, by selecting a range that is too high, it prevents the meter being overloaded and any possible damage to the movement of the meter itself. Safety measures. De-energize and discharge the circuit completely before connecting or disconnecting a multimeter. Never apply power to the circuit while measuring resistance with the multimeter. Connect the multimeter in series with the circuit for current measurements and in parallel for voltage measurements. Be certain the multimeter is switched to AC before attempting to measure AC circuits. Always start with the highest voltage or current range. Oscilloscope. An oscilloscope is a laboratory instrument commonly used to display and analyze the waveform of electronic signals. The oldest of oscilloscope, still used in some labs today, is known as the cathode ray oscilloscope. Modern oscilloscopes electronically replicate the action of the CRT using a liquid crystal display. A typical oscilloscope can display alternating current AC or pulsating direct current DC waveforms having a frequency as low as approximately 1 Hz or as high as several megahertz. Before you turn on the CRO on, make sure the intensity control is wound down. Turn the CRO on. Wait for the tube to warm up and start operating. Turn the intensity control up until you have a horizontal line which is not too bright. Adjust the focus control until you have a line which is as thin as you can get it. Connect a probe into the CH1 input. Connect the probe tip into the CAL output. Adjust the time-based control and amplitude control for CH1 until you have a square wave which takes up most of the screen and shows you at least one full cycle. You are now ready to use the oscilloscope to measure all sorts of waveforms. Fingerprint reader. A biometric fingerprint reader creates a high-resolution image of unique patterns of the person's fingers. Once the reader has recorded these patterns, it will ensure accurate recognition of the same person based on his or her unique fingerprints. Sensor. The sensor, which scans the fingerprints, is the most basic and primary part of the system. Processor. Then, there's a processor which stores the fingerprint images in a database. Database. The database is another important component of the device which stores reference numbers, PIN numbers, names, email IDs, employee number, etc. This data helps to match and identify a fingerprint with an individual. Screen and user interface. Depending on the type of device, There may also be a screen on board the device which will help the users to operate the device via a keyboard on the surface of the device. Software. Of course, there will also be a software sitting inside the machine too. This software's one and only job is to compare and match the fingerprints with the individual system. Safety measures. After installing the fingerprint reader in your PC, start the fingerprint management program. Place the top of your finger over the reader carefully so that it registers your fingerprint starting from the first knuckle. Press firmly and move your finger over the reader carefully till it completely passes over the reader. Pay attention to the prompts that your computer gives out to see if the reader has registered your fingerprint. Sometimes the program may prompt you to swipe your finger more than once if it failed to capture the fingerprints the first time. You can enroll another fingerprint in the same manner for others to gain access. Motor driver. A motor driver is a little current amplifier. The function of motor drivers is to take a low current control signal and then turn it into a higher current signal that can drive a motor. The most common values of maximum supply voltage are 36 voltage and 52 voltage. We also carry motor drivers with supply voltage up to 450 voltage. The number of outputs can be between 1 and 12, with the most common motor drivers having 1, 2 or 4 outputs. Precautions. Turn on and turn off should be done by operators or inspectors themselves. Internal circuit of the driver kept charged with high voltage for a while even after power off. Turn off the power and allow 15 minutes or longer LED display of the panel has gone off before performing maintenance and inspection. Disconnect all of the connection to the driver when performing the mega test to the driver. Otherwise, it could result in breakdown of the driver. Daily inspection. Main circuit voltage, ambient temperature, humidity, dust, abnormal vibration and noise, loose connection, cleanliness at front portion of the driver and connector. Periodical inspection, loose tightening, trace of overheat, damage of the terminals. Quadcopter. A quadcopter is multi-rotor copter with 4 arms, each of which have a motor and a propeller at their ends. In a quadcopter, 2 of the propellers spin in one direction, clockwise, and the other 2 spin the opposite direction, counterclockwise, and this enables the machine to hover in a stable formation. Before starting, the flight battery and the transmitter battery must be fully charged. Always turn on transmitter first and then quadcopter multirotor. Watch for visible damage such as loose screws, broken, unbalanced or damaged propellers, faulty connectors or solder joints, broken pipes, etc. Perform a pre-flight check. During the flight, improper operation can cause serious injury and property damage. Never fly towards viewers and avoid flying over spectators. Keep in mind that viewers could get close to the quadcopter multirotor without being aware of potential dangers. Always turn off the quadcopter multirotor first and disconnect the flight battery before turning off the transmitter. After the flight, make sure that there is no damage of the propellers. See the handling and safety precautions of LiPos. After a crash, the sensors and electronics might be damaged. Before the next start, everything must be checked.